ecosystems have evolved for survival, right? Droughts, floods, fires, invasive species. A lot of this is overlapping threats in terms of what we as humans and our networks deal with. And interesting characteristic that ecologists have found is that food webs embody a really unique balance of redundancy versus efficiency. And it's believed that this is because they have this need to grow and develop despite continuous perturbation. So when things are good, you're going to grow and develop as much as you can, but when things are bad, you're able to survive and recover, right? So kind of avoiding both excessive brittleness and stagnation. Quantification of this metric uses both structure and flow. So we have a more complex matrix where we have flow magnitudes. So at a high level, this ecological resilience metric, ecological fitness, depends on the amount of redundancy versus efficiency in your pathways, right? So how much are your pathways constrained when you go from one point to another versus how many options do you have to get from one point to another? So the two extremes are on the left and the right here, right? So we can see a chain, a straight linear line on the far right. That is sort of your one extreme, perfect pathway efficiency or constraints. This results in a degree of system order value of 1. The other extreme is a degree of system order value of 0. This is total pathway redundancy. Every pathway is turned on. And food webs are somewhere in between. And that somewhere is really interesting because it is termed the window of vitality, because they tend to cluster in this range that overlaps the 50-50 point of between redundancy and efficiency, but actually favors the redundancy side. So this idea that there's this window that these biological systems have arrived at that help them effectively use resources when things are not disrupted, but also be adaptable to survive and recover when things do happen. And these are unexpected disruptions that we're interested in. So we use this metric and this window of vitality to redesign a water distribution network. Right. So again, can we minimize freshwater using this bio-inspired resilience now? So we looked at designing this network for cost, designing it just to be as much like nature as possible. So have this ecological fitness value within the window of vitality as much as possible, and then sort of balancing costs and the ecological fitness. And so we ended up with 3 solutions. And what was interesting was the 2 bio-inspired solutions, right? So the combo and the just bio-inspired both did cost more. So that led us to think, was the extra cost worthwhile, right? So what are we gaining with that extra cost? And it turns out we're gaining that resilience, right? So it's doing exactly what we wanted it to do. It's mimicking the resilience we see in these food webs. So when we, again, did disruption scenarios, we looked at both disrupting the individual networks in this individual industries, these actors, shutdown scenarios. We also looked at just disrupting the pipelines. And what we saw in both cases, so connection breakage scenarios and actor shutdown scenarios, was that the bio-inspired versions, both of them, so the combo and the strictly bio-inspired versions, use less fresh water during that disruption. So again, it better survived that disruption. So you're actually, I guess, saving money. So to finish that thought, you are, despite that extra sort of upfront cost, you are saving money when things go wrong. And again, this might not be the right decision-making process for all engineering networks, but if you are concerned about being more sustainable from both an environmental and a resilience perspective, right? Because the most sustainable design, if it's not going to survive the next disruption, the next environmental disturbance, it's not a great design, then this approach might cost a little more, but you do save in the long run. So, a company producing tennis shoes might not care about what happens during disruption as much as a company producing, say, insulin. So taking this into consideration.